Hello. Hello.
Hello, sir. Am I audible?
Yes, sir.
Yeah.
Hello, good evening to everyone. Yes, sir, you are audible, sir.
Okay, thank you.
So this is Vimlesh Oja, Organizing Secretary of this STTP. I welcome you all in this 11th session and on the fourth day of this STTP. So I would like to introduce our distinguished speaker of the session. Our honorable speaker for this session is Dr. Renuka Prasad ji. Sir is Associate Professor and Associate Dean in the Department of MCA. Our Honorable Associate Professor in the RVC, Karnataka, Bengaluru. Sir is a highly enthusiastic and energetic person who always trying to bring changes in the way we make the learning. MCA energetic person who always trying the way we make the learning minds innovative and scientific approaches in their learning and respective the learner's freedom. Sir has completed his PhD in network security domain in 2012 and MPhil in cryptography domain in 2003. Sir has completed his PG, that is MCA, in 2002 and Bachelor of Computer Science in his PhD in and MPhil in cryptography domain, 5 international papers, and Sir has completed many projects. Sir has completed work that is also. Sir has the vast experience in the field of IoT and all. Has published 5 international papers and completed. So it is very pleasure to have you in the session, sir. I would like to welcome you again, sir. This session is now over to you. May you please start, sir?
Thank you.
And all.
Hope my screen is seen.
session is now over to you. Sir, this
Yeah, is the screen okay? Is it visible?
yes, sir. Okay, very okay, sir.
Thank you. So good afternoon, everybody. So just a moment, I'll take a minute. Just I'm setting up the
Yes, yes, sir.
well also. Yeah, I think I'm fine. So let me begin the session. Hello, everybody. So this is the agenda for the day. So I'll give a very quick introduction to Internet of Things, which includes some introduction to the concepts, applications, fundamentals, some fundamentals about what are things and what Internet around the things is being done, and few applications I would like to mention. After that, today I'll introduce you to the Arduino Uno board, and then essentially I'll introduce you the concepts and then what development boards, and focus will be on the Arduino today. So a bit of Arduino, about the Arduino Uno, and then the software, then concept about, how the breadboard is used, and then a few sensors and actuators will try to integrate with Arduino and see some minimal working. And at the end of the session, there's a very quick and a brief demo by one of my student who is also logged in. So he will just show you how a simple home automation relay operations also can be done. So he would at the end. So we'll see how the things go on, and how the flow will be. Based on that, we'll adjust it. So in this 90-minute session. So before going into the slides, so I would like to quickly uh, introduce you to very, very fundamental concepts, and then move on with other things. So it's we are talking about Internet of Things. So what is this Internet of Things? So let us try to understand. Okay. So these phrases, Internet of Things. So the focus will be on these things, and in context of the seminar, in context of the session, So what does this things stand for, or what do we have to understand? So things, as in sensors or actuators, electronic or electrical devices, so however you would like to call them as. Okay, so then these sensors can further be classified in many ways, actuators can be classified in many ways. All those things are fine. But we need to understand about these things. But what do sensors do? What do actuators do? And what do we do when we say Internet of Things? So to understand this, we need to understand our physical world. So this physical world we need to understand. Then we need to understand physical quantities. Then only we will understand why sensors are being used, why actuators are being used. To be more in a simplistic way, the physical quantities, it can be temperature, it can be humidity, light intensity, colors, so on and so forth. These are the physical quantities. The physical world is the one which now, the physical world around me, I'm writing something, I'm making some changes, I'm drawing a line. So this is the physical world, and the world we live. So that's the physical world we're talking about. Now, what do sensors do? Sensors can sense a physical quantity. The sensor's primary purpose is sensing, of course. The other terms, we can say that monitor. Sensing, or it can say monitor physical quantities. But what is actuator? Actuator actually controlling or controls. So however you would like to mention. Same thing applies to this as well. But actuators control the physical quantity. So in what way? So and what does this internet doing in the term or a phrase Internet of Things? We need to understand this. So I'll keep this here. So let's understand very quickly, uh, very quickly, what is programming. So let me tell you. So how is this mechanical programming will be like? Mechanically, if I have to program something, so understand this part. You all know what is this. This is a simple LED, anode, cathode. Okay. So the long leg is the anode, short leg is the cathode. In school time, we taught all these things. A bulb, you know, the pencil, etc., and all that. So I'm taking a coin battery. So you understand what I did now. I programmed mechanically for the LED to glow. The mechanism inside it is different. So the mechanism inside, what happens? So the electrons flow towards less resistance while flowing when the connection is closed. It flows through the LED, LED glows. All this is fine. But we need to understand that we programmed, we programmed this physical world around here to make the light or the ambience red. The same way, I can use other LEDs also. The same way I can use other LEDs also. So I am using now the blue. So maybe the light is little more. I'll keep it in the darker side. Yeah, you can see there's a blue color, right? So then the ambience, it keeps changing. Yeah, now you can see green. So what did I do? So I mechanically programmed to change the ambience or the physical world. I programmed the physical world mechanically. So I programmed the physical world. So what was the physical quantity? Light or the color, ambience, the light color. So that I could change it. So I did this mechanically. So if I have to do it programmatic way as in, okay, some automated way. So programmatic way, some automated way using some hardware plus software. So that is what our focus will be. So then what is this IoT? IoT is one way of programming the physical world. Okay. So when we say, why do we have to program the physical world? To monitor or control a physical quantity. So hope this is clear. If this concept is clear, I think rest would be easy. Now, so IoT is one way of programming the physical world to monitor or control a physical quantity over internet. Over internet. This can be network, a network which is wide area network, or a network which is a local area network, or etc. etc. So that's what the over internet, if you are able to monitor or control a physical quantity by programming the physical world, that is IoT. Practically, this is what it means. This is what it does. Practically, this is what it happens. So the I over the I in the Internet of Things role is that. Otherwise, all these automations are already there. Since decades, there are manufacturing industries. There are so many. I mean, there's so many automation is already there. Then what is so different about the Internet of Things? So that's what over internet it should happen, or over network it should happen, and as much as minimal human intervention, will be there. Okay. So now, how do we program the physical world? We understood. Yes, definitely. Some concepts we're trying to understand. But how do I program the physical world? So let me keep this. How to program the physical world? Remember, why are we programming this physical world? So we are programming this physical world either to monitor a physical quantity. So how do we do this? Okay, so here comes the presentation. So you could see on to the left, there are a lot of devices in the presentation. A lot of devices on to the left. Okay. And these are all some of the sensors, actuators I have mentioned. Okay. And here, these are the development boards. We program the physical world using these development boards, which in turn talk to these sensors. And over network, we will be able to program and help in monitoring or controlling a physical quantity. But why do we do that? That depends on the application of the project that we are focused in. So it could be health monitoring, it could be agriculture, it could be manufacturing, whatever it is. Okay. So now, so this is quite enough to understand all of that. So let's understand how do we do that. Okay. So let me show you how do we do that. So we can program the physical world using development boards. What are the development boards? What are the sensors? We need to understand. Okay, let's try to do. Let's try to understand those things. Okay. Hope this is not blocking. Yeah. Fine. So I'm keeping some of the sensors here. Okay, some sensors I'm keeping. So there are a few more. Yeah, even the camera. The camera is also a sensor, as in it's a light sensor essentially. Yeah, I can keep few. And 1 second, we'll also, yeah. This is just for showing, okay? A lot of sensors. And now there are actuators also. Then this is a buzzer. Okay, there is a motor. So please remember, all these are all 5 volts, operated in 5 volts. Actuators. These are sensors. This is water flow sensor. This is a water flow sensor. I'll just keep it aside. Of course, this is a digital keypad which can take inputs about some numbers. So this is a sound sensor. Sound sensor, touch sensor, ultrasonic sensor. This is a motor. So these are actuators. There's a buzzer. If I remove this cable, yeah, this is a buzzer. Yeah, of course, an OLED. Yeah, there are display devices. This is a e-paper, by the way. We have not seen. Okay. Okay. So then, yeah, there are few other display devices also. This is a OLED. Okay. So motors, buzzers, sensors. Now, since you have seen this, I can move them across, but I can keep it for your better understanding also. I can keep them here also. Now, let me draw some diagram so that the concept clarity will be there. So this one, sensor 1, sensor 2, sensor N, actuator 1, actuator 2, actuator N. Of course, you can add LEDs to this also. You can add LEDs. So there can be many. Okay. There's ultrasonic sensor, there's a touch sensor, and there is a sound sensor. And yeah, I don't have, there is a gas sensor, there's a flame sensor, temperature and humidity sensor. This is okay. There are a lot of sensors. Okay, so let's keep it. These are actuators. Means whatever the value you want to display, you can do that onto this. Okay. So then there are motors. Then yeah, I can have a simple LED or a buzzer. These are all actuators. So I can do some control. Now, how do I program the physical world? So I said using development boards. So what are the development boards? So here is a development board. This is Arduino board. This is Raspberry Pi board. Then there is Node. So what do we do? So then, when I say, when we say IoT, what do we practically do? Okay. So practically, we program this board because we can't directly talk to them because this device knows how to talk to them. So we program these development boards so that they can talk to these sensors or actuators. In turn, they can talk to the physical world around them. In turn, they can talk to the physical world around them. So there can be a physical world around them so that we will be able to monitor or control a physical quantity. Okay. So let me, yeah, I think this is better. So now, more precisely what we see, there are a lot of development boards. Okay. There will be a lot of development boards. This is a Pro Mini, Arduino Pro Mini. There is Arduino Mega, Arduino Uno, Arduino Pro Mini. There's Node MCU, ESP32. There's so many boards are there. In fact, I do have one more board. So this is also a development board where there are sensors embedded onto this. This is a touch sensor. You can build a piano. You can build a lot of things. Okay. Now, what is that IoT will do, or what does it enable us to do? For simplicity, I'll keep only this board, but while writing, I can still write and show it to you. Okay, so I'll move this. So these development boards. So this is you consider this as Arduino. Okay, so then this has Node MCU, and of course this is Raspberry Pi. So these are the development boards. Now, what do we do with IoT? So it's all about the network layer. So the embedded system play a lot of role here, where sensors will sense some physical quantity, so they will be able to transmit data here, all these things. So ideally, how do we program the physical world? Using development board. So we use development boards along with sensors, actuators. Okay. Now they will talk to these. This can talk to these. This can talk to this. So the same thing is implied here also. I'll write it in different color so that you will understand that this is also possible. So they will be able to, I'll take it as simple. For example, ultrasonic sensor. So what does it do? The ultrasonic sensor will of course trigger ultrasound and also help in sensing. Or temperature and humidity sensor will sense temperature and humidity. And then if it crosses something, there can be a buzzer here, which can be programmed to create alert. Now, after taking these values, that is the temperature values, or the sound level, or input from a touch sensor, taking these values to a development board. This can be either stored in a database, or you can store it in a file, or you can push it onto the storage area onto the cloud. So all these things are possible. Along while doing this, you can create, or we can create, lot of visualizations. So you can create visualizations. You can generate charts. You can generate GUI buttons and all of those. So this can be on a web browser. There can be a mobile app also. It can be, different. There can be variety of ways. It can be a mobile. It can be just works in a browser, web browser. So now, I hope you understood what Internet of Things is all about. So I'll bring back the concepts I explained. For example, you can see here, Arduino can talk to this temperature humidity sensor, get the value, and it exceeds something, it can generate an alert. Arduino can sense a sound and can, of course, do some other glow an LED. Arduino can get a touch sensor value. If it is touched, it can rotate a motor. Or it can do display display something on the LED, or it can do a lot of things. Okay, so these development boards play a vital role, and we need to understand how to work with these boards. That's what the key is all about. So I'll bring back whatever the definitions I was trying to tell you about. So IoT is all about, or IoT is one way of programming the physical world to monitor or control a physical quantity over internet. So that internet can be a local area network or a wide area network. But first, the fundamental aspects of all of those, you need to understand how to work with the development boards and how to work with the things. So these are all the things. These are the development boards. They talk to the things, and things talk to the things talk to the outside world. And either they help in sensing a physical quantity or controlling a physical quantity. So now, what are the physical quantities would be? So these are all the physical quantities. So the physical quantities include, it could be a position, it could be force, pressure, flow, humidity, temperature, light, radiation, a lot of things. So these are all the physical quantities which, for one or the other reason, depending on the industry or it could be on the domestic purpose, we would be willing to monitor or control those things. Okay, now, so as per the agenda, we understood some fundamental concepts of Internet of Things. Now we need to understand how do we start thinking to build or start working on those which will enable us to build IoT or IoT solutions. Okay, so now let's move on, do more stuff. Any doubts so far? I'll give 2 minutes time. So if you have any doubts, you can unmute and ask, or you can chat. I'll give 2-3 minutes time, because if the concepts are clear, so then it will be easy for moving ahead and explaining you more about the practical. I'll give 2-3 minutes time. If you have any doubts, you can clarify. Okay, so if unless you're asking any doubts, so let me focus on the workings. Okay. So we will be using Arduino Uno board. Okay, we'll be using Arduino Uno board, and we'll be working on the Uno board for the next half an hour or 1 hour. So okay, so we'll try to understand what is this Arduino Uno board. So how do we program the physical world? Okay, and then work with few sensors. So could that be a DH11 sensor, or it could be with a buzzer and with few LEDs. There are other sensors also which I can point at, but the time is the limitation, so we'll see. And of course, we do have a relay, and we'll see what best can be done with that also. Okay. Okay. So how do we program the physical world? Now, let us understand this board first. This is the Arduino Uno board. Okay. So now this Arduino Uno board, you can see, okay, exact the same one. I mean, you can, why I'm showing is, I assume that you might not have seen or you might be a beginner. Okay, if you already worked on it, then this session is of just a repetition. So I have kept a few images ready. So once more. Yeah, so I have this. So this is Arduino website. Yeah. So, yeah, exactly. This is the board I was talking about. So what is the size? So I was mentioning that, so it will be of the size. When I minimize, you will understand. So what is the size you should look at? The same board I'm trying to show. The color might be a little different. I'm just showing this. Okay. So in the same way, I'm just holding in the same way as it is on the screen. Okay. Now, so this board. Okay, let me give you one or two applications so that idea about what and all we can think of building. So you all have seen car dashboards, refrigerator dashboards, as in display panels, and then many other devices which are smart, you know. So those boards you have seen. So typically, one or the other microcontroller will be running inside it, and it keeps prompting you. Can you give input what you're supposed to do? You want to tune into FM, or you want to play MP3 files, or you want to receive a call, or something like that. So all that will be here, okay, stored here. So now, what kind of programming we need to do? We need to understand. We need to understand these development boards. Of course, one is based on the microcontroller, and tomorrow based on the microprocessor, that is Raspberry Pi, where you need an operating system. To work on this Arduino Uno board, of course, if you want to work on the laptop or computer, you need a USB cable because USB port and all of that. No, but you don't really need a complete operating system to flash onto it. Whereas in the case of microprocessor, it requires, because it has to be driven and all of that. Okay. So we need to understand this board. Then it's easy for us to understand what do we call it as programming the physical world and all. So the components of Arduino Uno. So this is where the microcontroller will be placed. So that's what you saw just now. I showed you the images. So this is a microcontroller. In fact, you can see the number. It's Atmega 328 PPU. That's the microcontroller, which is the heart of it. So we need to understand that you all have to understand, in fact, that you will be, or you have to assume that as if you are a microcontroller, so that you will have to take some instructions and execute it. So to understand what microcontroller does, you need to learn the language that it supports. So Arduino programming language is what I am trying to refer. Okay, some modules or some functions we can introduce, not all of them because of the time limitations. Our session is not about introducing Arduino programming language, but about, of course, using them. How do we build applications? So that's the one of the microcontroller being used. And there is one more microcontroller. There's one more microcontroller here. This is on a system on chip. This can be lifted. So from this edge, so you can see a dented edge. You can easily lift. This costs around 80. This chipset costs around 80 rupees or something. But there is one system on chip. So this one controls or takes care of the USB communication. You can see here, there's a USB port. USB communication between the computer and this board. Okay, and there is a clock. You can see here the clock. So the clock that keeps the board ticking. So 16 megahertz clock. So it is labeled. This is the oval shape. Okay, so this is 16 megahertz clock. So this is a drum jack, which is used to power DC power. So this is the USB slot. I mean USB port, which has to be connected to work with the computer. Now coming to the key
Sir, we
component.
use flip-flop in Arduino.
Sorry?
Flip-flop.
Okay.
We use flip-flop also in Arduino to manufacture the Arduino.
So I'm not discussing about how this is manufactured. I'm just telling about how what are the components of the Arduino board. How do we use this board to build small applications? So that's the focus as of now. There are a lot of other components which are not seen here. So what is seen, I'm just trying to explain you the components so that you will handle it safely in case when you are working. That is the agenda of the session. Is that okay?
Okay, sir.
Thank you. So yeah, so now the key aspect of the board and the core of what the IoT when we call it as. So how do we program the physical world? We program actually this microcontroller. This microcontroller will talk to these pins. So there are three types of pins, essentially labeled as digital. These are the digital pins. Okay, of course there some are prefixed with tilde symbol. This image, okay, I can show from this image. So there's okay, you can see digital pins on top, 0 to 13, 14 digital pins. At the bottom, you could see analog pins here. And some are power pins. These are analog pins, A0, A1, A2, A3, A4. Okay, so the same labeling is here. So to draw 5 volts from this board, this is a pin we use. To draw 3.3 volts, we will use this. There are 2 ground pins and 1 more ground pin here. Okay, to understand, okay, this is about the Arduino Uno board. So what do we do using this? So if you remember the mechanical programming, so you will understand what we will do this now. Okay, this is what we did before. So if a clock battery or this battery can make this LED glow, so how to do programmatically using this development board? So now all of you should start thinking about this, and we need to understand about the development boards and the language it supports, rather the microcontroller. Now, please remember that you're all sitting inside it and you talk to these pins. These pins will be connected to these components through wires like this. Of course, there are multiple ways to connect. So like this, Like this, there are different cables which will get connected, like this. Okay, we need to do that. All that I'll show you to you. Just understand. Through these pins, either we will read a value or we'll give some instructions so that if there is an LED, it should glow. Or we will, if there is a buzzer, it will glow. Or if there is a, if there is a OLED, it will display some value. Or if there is a e-paper, which I showed to you quite a while ago. Is that e-paper? Yeah. E-paper like this, which doesn't require power to show the values, but requires power to change the values. Once you program, that's fine, done. So it will stay in the any project which requires consistent display. So this is the best one. You can put it on the badges. You can make badges. A lot of things you can think of. And if you connect a Wi-Fi module to it, so from a remote place you can push the data that has to go onto this. That's the beauty of it. So there's a wonderful project. People do it. You can flash the rates of certain items. But while programming, it has to be connected. But for displaying, you don't need. Once you flash, so you can, you can just do things like this and just configure your, like a badge. You can wear it. A lot of things you can do. Of course. Okay, so now let's understand about the. Now we understood about the software part. So I'll just take off this. 1 second. Let's see. Yeah, you can see. This is an open source electronics platform. As in, the sketch of this is available. Gerber file. You can make your own boards also. So this is the Arduino Mega board, where there are more number of pins. Why do we need more number of pins? Once you understand the smaller one, you will understand the bigger one. Yeah, please remember there are a lot of capacitors. There are a lot of capacitors are there to filter the power, filter the variable power that comes into it, and this requires consistent 5 volt. The operating voltage is 5 volts. So of course the input can be varied from 5 to I think 12, sometimes 14, but it operates at 5 volts. So it requires do not power at the same time using this drum jack and this. So board will, the microcontroller on the board also may burn. Now let's understand the Hello World program, or how do we write code onto it, connect the components, and then start working. Let's move on to that. So this is the Arduino website. Okay. So if you, there is of course the hardware section where there are lot of hardware and the projects listed. If you have time, please go through the hundreds of projects that are listed and very good resources also, and the softwares. So to work with the Arduino Uno, we need a software. Is it not? So this software is also provided by the company, as in the company in the sense Arduino. Okay. So they provide the software. You need to choose wisely. So what you need to choose wisely is what is your architecture. If it is a 32-bit as in i3 and below that, and the Linux machine, you need to download this. If it is above i3, so better you use the Linux 64-bit. And if you are using Raspberry Pi basic versions with ARM architecture, you should use this Linux ARM. And Linux ARM 64-bit, the processors with 64-bit processors, Raspberry Pi 3B plus and all should use this. And of course the other operating system, which I have no experience. And if you wish to do it, you can download and use the IDE. So this IDE provides the convenience of flashing the code. By the way, this is nothing to do with the one which I'm moving is nothing to do with IDE. This is a floating tool which I use it for streaming these things onto the browser. I mean onto the desktop on my laptop. So please don't get confused. Okay, this is the IDE. So if you get confused, I can reduce this and show you. Yeah. So this is the Arduino IDE. So it has several sections. As in, this is the code area. So there is a menu bar, which has a lot of menu: file menu, edit menu, sketch menu, tools menu, help menu. Okay. So then there is of course message area. This is the message area where you can see what activities, logs, whether it is compiling and all that. So here you can see it shows also whether it's done uploading, done compiling and all of that. And then at the bottom right you could see there is indication telling that to which port you are connected to. Then of course when you click on the top right you get to see a magnifier link here. If you click on it, there is a soft monitor, as in this is a monitor provided by the IDE, just in case if you want to see some value or give some value from the serial port onto the microcontroller. So this is where you can give input, and this is the area where you can see the output. So this is a serial monitor. If you click on it, so the serial monitor, so all these are provided a part of the IDE, integrated development in this. So before working, so ensure that you are connected to the Arduino. Ensure that you are connected to the Arduino. So I've already done some wiring, but I can show you how do we. Just a moment. I'll take one cable. Yeah, I can show you. Already some wiring I've done, but I can show you the fresh. Piece. Yeah, you can see this is the Arduino. So connect it like this, and of course the other end will go to the laptop. I do have laptop here, of course, at the other end. So I've already connected one, so I'm not connecting. Okay, let's do some fundamentals, as in very fundamental thing about this. So what is that fundamental thing? So the first Hello World program, like typically everybody teaches Hello World. So let's do that, and understand how to do it. And how do we start? I told you this is the long leg of Arduino. This is the long leg of Arduino. So this is the long leg. This is the long leg, which is long. This is a short leg, where the pins are not exposed, but the hooks are provided. So one feature I did not mention. There is an LED here. There is an LED here. Switch off. You can see I'm just covering it. An LED is already glowing. That is called built-in LED. And built-in LED is connected to pin number 13. Pin number 13. Anode. Built-in LED's anode is connected to pin number 13. Okay, please keep that in mind. Okay. So now. Okay, so I have connected the Arduino Uno board to the computer. Let's understand how do we work with the IDE. Okay. So how do I detect? How do I know that how do I know that I am connected to it? So in the tools menu, there is something called port, and there is something called also board. So in the board we should be clear, because ours is Arduino Uno, and the port is /dev/tty/acm1. In Windows, you may get something called COM1, COM3, COM4, or something. I don't know. I have not worked much, and how does it list? How does it label? So since we work on Raspberry Pi, and Windows is not meant to be running on the small devices, and not suitable for IoT, because IoT requires more secure kernel, where Raspberry Pi can run, or where Linux kernel can be easily ported onto a lot of devices which are quite good enough. Like for example, your access points itself. Majority of the time, there's a Linux kernel that will be running, and you will be given a URL to access it. For example, 192.168.0.0.1. So assume that if you want to secure your IoT secure your IoT solution. And if you have to put a firewall, so the best is the Linux kernel. Anyway, so to understand that, you need to also understand what is Unix file system. That's for your further studies, or further understanding. Please go through about Unix file system. So if you understand that, that's quite. That will be very beneficial. Now, let's understand how do we do a basic programming. So this is the code area. So I told you this is the tools menu and sketch menu and all that. You verify first and then upload. So the programs that we write here, okay, where did I take this program from? So Arduino provides a lot of default examples. I have taken it from here. Basic Blink, just a Blink program, okay. So there are a lot of default things. Please, if you even just try these default things, it will take 1 year to for you all to just understand all of these and to get all of those devices and experiment. So I'm just taking one basic Blink example and make you understand how do we do the basic programming. Okay, so this is a Blink program. Now, yeah, file new. If you open a new file, this is what the skeleton you get. The Arduino program has two functions. One is called setup function and other is called do function. The setup function is to do one-time works. Loop function is to do repeatedly certain things. So what should I set up? Let me take the default example here. Whenever we use these boards, I mean the development board. This is a microcontroller. The pins which I mentioned, have to be put in. These are all general purpose input-output pins. So either you can draw input from them or provide output to it. So from this, you should control. That is the point. Either you take some values or give some values. Okay. So here is what I told you. I told you that we need to understand about the Arduino programming language. So please refer some of the links like this: Arduino programming language. So this is the some reference. There are hundreds of references you get. So if you go to this Arduino reference programming reference, so it will list a lot of functions that are being used. Okay, I'll show you at least one or two, so you will understand how things are used. So you should learn this language first, at least while working. Also, you can learn, and then you'll have to work on the device. So now there is a function called pin mode. You have to decide what type of in what mode the particular pin will work, either as an input or as an output. Please understand. Please understand. We are talking in the context of microcontroller. Output means the pin, whether we will give some output to it. I repeat, whether from the microcontroller to this particular pin, do we give some output or give some instruction or do some controlling. That is the output. If you put it in a input mode, then you can read some values from it and take it into the microcontroller. So it's very important whether we put this pin in an input mode or output mode. Okay. So now I told you that default there is a default LED or built-in LED. Built-in LED I showed you also. You can see there's a built-in LED that is glowing as well. You can see here. There's a built-in LED, right? So which is glowing. That's exactly pointed to the to the anode of the LED. That is the pin number 13. So LED underscore built-in is set to output. That is pin number 13. So you want a confirmation of it. So here is the programming language reference. Control F. LED. See, LED underscore built-in. These are all the constants. Whenever somebody says LED underscore built-in, the value is 13. You can click on that and give description for you. See. Yeah, input, output. You can see it. Default built-in LED built-in. Most Arduino boards have a pin connected to an onboard LED in series with a resistor. Of course, they'll have a default resistor. So the constant LED underscore built-in is the number of the pin to which one onboard LED is connected. So there is an LED and the anode of it is connected to it. And what does it pin mode do? Let's understand this also. Control F. Mode. So pin mode function configures the specified pin to behave either as an input or as an output. So it expects two parameters. One is the pin number and the other is the mode. The mode can be input or output. So exactly this is what it is. Why output? Because there is an LED. So we have to put it first. We have to set it, and this is a one-time setup. Only whatever things we have to set up once, use a function setup. Anything repeatedly you want to do something, we use a function loop. Then we need to understand digital write function. Digital write function LED underscore built-in, comma high. High again it's a constant which will give 5 volts to the that particular pin. Which pin? Pin number 13. When you give that through the anode, and there is wherever there are 5 volts given, and it flows to the cathode, and the current passes, there is a less resistance, so it will be the cathode will be grounded. So current passes, LED glows. So when it is set high, and then a delay for 1 second. When you say high and then low with 1 second delay, we feel as if the LED is glowing. This is the simplest program. Now, once we make sure what is the port that is connected, once we make sure what is the board that is connected, all that we have to do is go to the sketch and menu and say verify, compile. So it does compiling, and then sketch, upload. Or you can use control or control U, so it is uploaded. It says done uploading here. And in the output you can see LED glowing. Maybe you are not able to see. Now you could switch off the lights. You can see an LED glowing. So you may not even understand that. Now you understand. I mean, you may not be able to make out the difference. Now you could see to the pin number 13, I am connecting the anode and the ground. So this is the Hello World program. So this is how the journey begins, where you start learning a language which a microcontroller understands. So once you understand through the development board, once we start doing, and then once we start interacting with the outside world, we program the physical world around it to control, or either we monitor or control. Here we are controlling the ambience. So for a moment it blinks, for a moment it makes it blue, and for a moment it doesn't. Okay, so like this it starts, and we have to continue. So I had mentioned about some sensors, actuators, and all of that. So due to the time constraint, what I have done is I have already done some wiring, which I will very quickly introduce how do I do it, and then move on. Okay, so we will be using the breadboard. So I assume that you may read later also. So the breadboard is configured like this, like a pipe. You can see here. First observe the structure. So on top, you can see here. On top, there are 2 rows. These are called power rails. And here vertically they are connected. Okay, like a clips, like clips there will be. Okay, if you rotate this, there will be hooks where for prototyping and all we need these breadboards where we'll hook up different types of wires and we start working on the. Okay, so now I will like this we will have to hook up somewhere. So we will have to, if there are devices are powered, then we will be giving power. I think there is some disturbance. So may I request the coordinator to check who's that making. Yeah, thank you. Okay, fine. So you take care of it. So I'll focus on this. Yeah, like this we may have to hook up. Like this we may have to hook up. Like that, I've already done some wiring. I will show you how did I do that, and very quickly I can show you one or two programs so that you will all get some fair idea how do I do it. So like here you could see one LED is connected. I'll remove all the components so that you will not get confused. So there is only one LED here. Of course, there is RGB LED, which I'll move it this side.
इससे क्या होगा? ऐसा तो हमने कभी किया नहीं है। मैंने इससे गुड़ की नहीं गई, ये रहने दो। जैसे नजर उतारते हैं ना, वैसे ही है। पहले आप लोग मुझे बताइए कि क्या बात है, क्या छुपा रहे हैं आप लोग?
So the organizer, could you please check who is making the noise? It's disturbing. Okay, so thank you. So now I've taken one LED. So let's understand how do we build something like a traffic signal. So I will have to hook up another LED. So this is how I hook up. So I'm just see, this is anode, cathode. I'm maintaining that, the long leg onto the left. So like this, I understand how to hook up the wires, and like this, I should do it. And I'll have to use different types of cables. So here, male-to-male cables are there. So like this, we need to understand. Okay. So like that, first understand how to hook up the components onto the breadboard, and then the programming part of it, within 1 hour, I may not be able to show everything. So like this, we need to understand how to hook up the components first. So like there is an LDR sensor here. So the LDR sensor is here. So if I learn how to connect it, and then programming part is next. So we need to understand how to connect these components. So I will take the one which I have kept all the things ready. Okay, ready as in I will explain you the circuit what I have done, so you will appreciate. So then how the things are happening. Okay, so you could see this is the Arduino board, and there are certain things that are connected. So and I will write the diagram so that time you will be more clarity. So I'll take few sensors since the session is just another half an hour. So I will try to demonstrate these things, and also I've told my student to give one more small demo. I hope Danush is ready with that also. So it will help you all to understand how these things are built. Okay, my purpose was to introduce you Arduino hardware. Now the software is introduced. One Hello World program we've done. We'll take a small application, and I'll show you the circuit diagram, and then the connections. How connections are done, I've shown you. How to use the breadboard, I've shown you. So very quickly, now I'll show you how to build a simple project. So I'll show you the circuit diagram now. So red, green, blue. I'll take red, green, blue. I don't have a green pen. So red. Okay. So there are three LEDs. Okay. So there are three LEDs. Let us take these. Okay. So there are three LEDs, and of course there is one ultrasonic sensor. There's ultrasonic sensor here. So it has 4 pins. So the 4 pins, I'll take it from here. The ground pin, trigger pin, echo pin, and VCC. This is what I have to connect to the plus, and this has to be the minus, and this has to go to the Arduino. And then of course, I do have DHT11. I do have DHT11, HCSR04. HCSR04 is the ultrasonic sensor, DHT11 is the temperature and humidity sensor, and all of these are Adafruit from the Adafruit. I don't think I'll be able to tell you the process of installing drivers. Let me see if time permits, I'll do that. So in the DHT11, in this one, there are 3 pins. Of course, usually you can see 4 pins. So onto the ground, okay, so this is the center one is the data pin. Onto the left of the data pin is the ground. Onto the right is the VCC. So the VCC will go to the plus and ground will go to the minus. And here, so here the LED, so assume that we can build a traffic pole kind of thing, plus minus, and this one plus minus, and here plus minus. So now if there is an Arduino board, so how do we attach all of these? So I will talk only about the pins. So if this is the slot where I will connect to the pins, right? So I will show you now how to do that. So this is red, green, blue. We can of course put one buzzer also to it. So I'll add the buzzer component to. So I'll add the buzzer to that also, plus minus. So I'll take pin number 2 to the red LED, 3 to green, 4 to blue, 5 to buzzer, and trigger pin I'll use 6, echo pin 7, and DS temperature humidity sensor data 8. So what should I do? So I should connect a wire to this one, connect a wire to this one, connect a wire to this one. So then this will go, 5 will go here, then 6 of course will come here, 7 of course will come here, and 8 of course will come here. First I should learn how to, oh sorry, I made a mistake. Anyway, that's okay. 8 or 9, I will connect 9. And this will be labeled 0, 1, 2, 3, 4, 5, 6, 7, something, 8, 9, of course. Okay, assume so. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so you can connect it accordingly. So my drawing might not be so perfect, but this is how the wiring is done, and the wiring is already here. But I will exactly give you the table in which. So I hope this is understood. Exactly the table in which this is already connected. Okay. So I will take this table, what is the Arduino pin and what is the device, okay. So red is connected to Arduino pin 2, and green LED is connected to 3, green is connected to 3, and blue is connected to 4, exactly on this one I am just telling. Then this trigger pin and echo pin, 6 and okay, 6. Black is 5. Trig is 5. Echo is 7. And then. Oh, sorry. Echo is 6. Then buzzer anode is 7. Okay. And DHT11 signal pin is 8. This is the connection table. This is the Arduino pin. This is the component or things I am connected. Now I have to do the programming. Okay, so I have done this. I will connect these. I'm connecting these, and I will teach you how to do the program. So as soon as I do that, you could see LED glows because plus and minus are correct. Okay, same way. And I have used some different types of wire so that it is slightly easy for me to move around. And there is a buzzer here, and there are 3 LEDs here. So hope you can see all of them if I zoom it. So this is ultrasonic sensor. This is the temperature and humidity sensor DHT11, and this is the buzzer, small buzzer, piezoelectric buzzer, and there are 3 LEDs, red, green, and blue. Okay, so this is what the wiring is about. Now let us understand how do we do the coding. I do have some examples ready. Yeah. So I'll explain you the concepts, and one by one we will understand. So first, okay, very quickly, let's do 3 LEDs, and then we'll see how do we mix that buzzer with 3 LED. Okay. So let me show where it is. So hope we know the table now. Okay. So our program buzzer with 3 LED, 3 LED, red is 2, 3, 4, and buzzer is 7. Okay. Let us understand this program. Buzzer pin, I'll make it 7. Red LED 2, 3, 4. This is okay. Okay. Let us. So this is how you first create a variable and assign the pin number. Then it is easy for you to initialize. So in the first built-in function, I mean the LED blink function, you could see we had set we have to first set the pin mode. So right now all our output. So here of course I have not connected the LDR pin. So LDR pin, I think LDR pin A0. So I don't think I'll be able to show that right now because I don't think I have that much time. So first I'll show you the output pins. Okay. So then comes what is that all that we have done? So instead of making one LED high low, we make all the LED high low. So that's all. Okay. So the same thing is repeated for all the LEDs. The same code repeated, only the variable name changes. Okay. So all that I'll do is I'll use a shortcut to compile and upload. So this will do the job. As soon as I do that, you can see what happens. So this is what it's happened. Okay. So if you want to show it, if you want me to show big, you can show that. You can see here. So this is a traffic pole kind of thing. I mean, of course, if you'll have to adjust all the other things and all. Okay. So now this is the simplest program where you can understand how to use the LEDs and then build a simplest solution. So now let us look into some more. I have a DHT11 sensor, isn't it? And then of course, buzzer with 3 LEDs. Then ultrasound sensor is also there, and yeah, temperature and humidity sensor. So this requires a driver. So the drivers are these are the two driving files. So how do we install driver? I'm sorry, I don't know how much time I have, but I will still try to. I still try to show that. Okay. Mm, so the Adafruit is the company. So Adafruit DHT11 GitHub. So this is how they will deploy and keep the driver. We need to download them. Once we download, like here, if you download this, it will go to a zip file. So that zip file contents. So whenever you install Arduino IDE, you will see that there is Arduino one version. It will be there. In that libraries, all of these DHT11s, all of these libraries will have to be extracted here. Like that I have done for DHT sensor master. I have done that. Okay. Adafruit underscore sensor, all of these. Okay. So once we do that, so why do we need a driver? Is because so from the driver it will be able to sense and communicate to the pin, communicate to the microcontroller. Now I've considered data pin as 8. So hope yeah, data pin as 8. So then there are two things here. There's something called serial.begin we need to understand. So this is the serial monitor. So if we have to display something onto this one, we can do that. You can do that with this library called serial library. You'll have to go through the documentation of serial library. If you just search Arduino Arduino serial, it will tell. And DHT is for that device. See, here I'm doing that initialization. Through this object, you begin the communication. So this is how you do it. I'll show you. And there are functions, simple functions to read. DHT.read humidity, read temperature. And the same thing, you can display it on the serial monitor. And the same thing, you can send it an email also. Not from this program, but there are other ways. Tomorrow I will show it to you. Now I will upload this code using the DHT11 I mean, we are using one sensor. For that you can see the pin mode and all of that. Now you might be wondering, where is the pin mode, where we are not using all that you might be asking. So that is taken care by this library. Our only thing is you have to mention what is the pin number. Okay, so it should read. It has done uploading. To see the output, click on this. You can see temperature and humidity values. Humidity is 95-degree, temperature is 28. Of course, not the exact value. Humidity is not so much here. Uh, yeah, these are all prototyping boards, not the industrial grade sensors. Don't consider that these are the highly precision ones. Yeah, they are okay. That's all I can say. So now there is ultrasonic sensor also. I'll show you how to use the ultrasonic sensor. The prerequisite is that you need to know how the ultrasonic sensor, I mean how the sensor works, as in the concept of echoing. So when we go and stand in a place where it echoes, you should understand if it has to be heard, you need to give a gap. Like that, one pin, trigger pin can trigger the sound. I mean, I'll show you from here. Then you will understand. One of the pin here, you can see here, there is something called trig. There is something called trig pin. There is a trig pin. It triggers, this pin will trigger the sound, waits for some time, trigger the sound, wait for some time, and echo pin will receive if there is any blocking. Okay, so now how do we, for this you don't need any driver. All that we have to tell is which are the trigger pins. So let us look into our connection table. So trigger pin is 5 and 6. Yeah, it is maintained. Red LED is 2. Buzzer pin is 7. Yeah, buzzer is 7. So there is a code. Of course, there is a logic. All of that. The logic is about calculating. How do we calculate? So once the trigger, once you set a particular pin to high, it triggers the sound, and once you put it low, that time once you give a gap of 10 microseconds, at that time there is a function called pulse in, which it will take the value from the echo pin. So here you could see an echo pin. So when there is a gap while triggering, it's like doing like this. When I say, so there is a gap. During that gap, it will start sensing if there is something. After that, of course, if something is coming very close, we can write the code in such a way that some LED can glow. Let me see how these things work. I'll show you the outputs first. You see the output, understand what and all we can build. Okay, so that will give some idea to all of you. So let's understand the serial monitor. Yeah, it's showing 1500 because it's not so accurate. Now you see what I'll do. I will keep this here. It is taking the value from the shirt or my body. So I'll show you this where I'm keeping it. Now you see I'll keep it very close. As and when it becomes 5, I think LED should glow, or a buzzer. Yeah, you can see it. So red LED and a buzzer, both will glow. Okay. So there are high resolution ultrasound sensors. You can use it in the farm security, industrial equipment security, even your lockers. So many things you can build. So I'm trying to explain you. Different components and see how best it is possible. The same way, if you want to do some automation like home automation, you can connect a relay switch to 3 or 4 components and you can do it. I'll just check if my student has kept his demo ready.
It's ready, sir.
Ready, Dhanush, I will just stop presenting so you can start. Where is this? Multi-participants can share simultaneously. Yeah, can you try presenting?
Yes, sir.
Yeah.
Is it visible, sir?
Yeah, D is something, D is visible. Okay, or should I do something? Wait a minute. Yeah, you can proceed.
Okay, sir.
You just show the connections and how things go on.
The video is visible, sir.
Yeah, somewhat. Yeah, that's fine. That should be okay. You just brief what is being done there.
Okay. So over here I have a touch sensor. So this is the touch sensor what I've connected to the Arduino board. From the touch sensor, I'm taking an input from the touch sensor and switching on the LED bulb. So this bulb is connected to the AC. So this is a small example of how home automation can be done. So this is a 4 module relay. In this, I'm using only one part of the relay to switch on the AC powered light. So in this example, I'll just show you how it works. So this is the touch sensor. So whenever I touch the sensor, the relay gets powered on, and the NO and NC gets connected, and the bulb glows. So again, if you want to switch it off, touch sensor. So if you can see in the program, oh yeah. See, I've connected the touch sensor to the pin 7. So this is the pin 7, and I've connected the relay to the pin 3. So these two pins, so whenever the condition of the touch sensor becomes 1, the relay gets activated, this relay, and the LED glows.
Yeah. So
Yes, sir.
yeah, Dhanush, thank you. You can stop presenting. Yeah. So I hope you got some. I hope all of you got some. Yeah. Yeah. So is there any? Yeah. Okay. Fine. Hope my screen is visible now. Yeah. So like this, my suggestion is that we need to understand the things first, as in the components, and then how to work with each. So we have tried to, we have tried to introduce you. We tried to introduce you some of these. Okay, some of these. So Arduino. So this was the agenda. So I was just trying to introduce you Arduino hardware, as in Uno board, and then the Arduino software, as in IDE, and then the breadboard you saw, then few sensors, of course the sensors, DHT11, then ultrasonic sensor, ultrasonic sensors, and then of course the actuators. Actuators are relay, what the student showed, Dhanush showed, and then of course you saw LEDs. There were other also LEDs and all of that. So I didn't do anything. So we tried to demonstrate. We tried to demonstrate a combination. Try to demonstrate a combination of all of these, or some of these, and understand how to build a solution. Okay, so this is what we have done. If anybody wants to know more, understand more, of course you can email me. I will reply. I will reply to your questions. So I'm pointing those. Pointing my email ID, and also I can help you if you wish. I can help you to figure out if there are some issues. Okay, resolving if there are some issues. So now over to you. If anybody has any queries, so you have, time is 4:20, so 10 minutes question and answer session. So this is what within the given time we try to introduce. We try to introduce the concepts, some concepts about IoT, and I mean, practically, what is the definition, some concepts, fundamentals, then how do we program the physical world using the one of the development boards, that is Arduino, by connecting it to some of the sensors and actuators to monitor or control a physical quantity. So this is what we are able to do it. So now, yeah, I think I will leave the floor for the questions. If you have any questions, you can unmute and ask, or you can type. Yeah, so some forms. So you have another 8 minutes, 8 or 9 minutes. If there are any questions, I am happy to answer. Okay, if there are no questions, the organizers can decide to wind off or not. The coordinator, please take care.
So, thank you, sir, for joining in this session. We are very thankful to you from our end of organization team. I request you to please join at your scheduled time. And thank you, participant, for joining us in the session. We will meet tomorrow as per the schedule. Thank you very much, sir.
So tomorrow 2:30. Hello.